Okay, we're on now. Well, greetings. Welcome to the last day. I know it's been a long week, but with all these training sessions, we are going to start once again with a quick Menti survey so we can assess where things are at and what people's knowledge is. So if you can get out your phone and jump in. So this is the HDM4, HDM5 session. Personally, I'm looking forward to it. I've got Henry Corelli here, Professor Corelli, who I first met back in 1995 when he was leading a lot of the work and I was but a young engineer, enthusiastic, and this went on to become the basis of my PhD and future career. So it ages us both when I say that. So if you've logged in, what have we got? 7 logged in there. I can do a quick head count almost at this stage. I think there's still a couple more, but everyone's fine there. I'll do the first question. So this is a pre-workshop. So again, just your role, just who do you represent? That's all good. And then the which region? Okay, we'll move on to the next one. So how would you describe your current understanding of HDM4 from the very limited through to the strong understanding and usage? If Henry doesn't say he's got good good understanding here, we're all in trouble. That's all good, thank you. We can remove that person as an outlier. Okay. Then what do you know of HDM5? So are you at the stage you didn't know there was an HDM5 coming, or all the way through to you have pretty good knowledge? Okay. I think there's one more question. Oh, it's just about, do you know much about use of HDM4 in the modelling of climate change impacts? So there's didn't know it could do it, all the way through to have been there, done that. Thank you. I think that's the questions done. We've got 12 responses, so that's all good. Oh, 3. Oh, we're doing oh, sorry, I skipped over that one. 3 words that come to mind when you think of HDM4. Input intensive, data, complex, fun. Somebody needs to get out more. Okay, thank you all. So I will stop sharing my screen and I'll now get on to doing the first presenter. So first presenter is Rowena Cham. So Weena, so Weena is a senior economics officer in the Economic Regional Cooperation Department of ADB. Over 20 years of experience in conducting economic appraisals in the transport sector. So Weena is ideally placed to talk to us about HDM4 within the ADB context. The floor is yours.
So thank you so much. I was also looking at the responses in terms of like the questions on the HDM4. I'm not really an expert. I've been attending trainings that ADB has been providing for our staff and also for our DMCs, and continuously you learn as you participate in this training. So I think more of like the main users, the road agencies and the our evaluators in our DMCs, they're probably more experienced than me in terms of using the HDM4. So I'll just, for this morning, I'll just give a short presentation in terms of incorporating the wider economic benefits in the evaluation of transport investments. I come from a department where we, screen projects for evaluation for projects that ADB finances. And HDM4 is being used in some but not all our projects in transport. So whether because HDM4 is mainly used for the road sector, but then the case for transport investments, it's usually when you think about transport investments, it's made in terms of the proposal is made in terms of what its impact in terms of the economic performance of a country. So it can you can also think of it as a catalyst for more private sector investments or increasing jobs or boosting the economic activity in a locality or a region. So these impacts, and we call them wider economic benefits for the lack of a term for these are usually not captured in our traditional way of doing economic evaluation or economic analysis. In HDM4, the focus is still when we have the results. The focus is still on the usual direct benefits of transport investment. So these wider economic benefits, they go beyond the usual CBA, cost benefit analysis that we usually employ. And how do we actually capture this? So at this point, with the upgrade and also like, how we do our evaluations, so do we kind of like, the methodologies that are out there. So how do we actually incorporate this in our evaluation? Where? Down? There? Sorry. Okay, just to backtrack. So why does ADB do economic analysis? First, for our ADB colleagues here, it's because it's our mandate. So in our charter, we are required that all the projects that ADB finances should show that there's economic efficiency. So there's a requirement for our projects to have this economic analysis link document where it shows that there's an analysis undertaken that projects are efficient. So we have a threshold in the bank. We follow, at this point, we still follow the 2017 guidelines. And currently, we're thinking of already starting to do some updates on it, given that there should be some incorporation in terms of what our economic analysis should cover. So again, so we do economic analysis because both ADB and the government do a lot of things. So in terms of ADB, we use it also as a rationing tool. Each of our DMCs would have a budget envelope also in terms of projects, similar with the government. Annually, there's a budget that only government can only provide a certain amount of funds for capital investment. So it's a tool that we can use. So it can help us ensure value for money. In ADB, we defined it as effective, efficient allocation of resources. We'd also like to see that these decisions are linked with our development plans, and in ADB, it's linked with their CPS. Our CPS are linked to the CPSS are linked to the DMC's development plans. So this, and policies, including jobs, poverty, and environment. Of course, economic analysis is a tool to help select from a range of alternatives. And again, so projects should have a development impact. So this economic due diligence is required. And when we talk about development impact, I think that's the disjoint that we have with, when we use cost benefit analysis, because development impact is a larger term. It covers more in terms of what would this impact would result into, society, social welfare. So, well, in some, so we assess the economic analysis assesses benefits versus cost of a project. Okay, so why do we invest in transport? Everybody in this room who are transport practitioners know all these things. When we see projects, the first thing that, in the project rationale, they say, oh, it's supposed to increase accessibility, right? It can reduce transport costs. So that's one of the aim of proposing these transport projects. It can lead to lower cost of goods, decrease in production costs, especially for, roads or other transport investments that can actually support freight. Now, because of climate change, so it is a way to address emission challenges, especially for transport policies that support, given that we each DMC would have these NDCs in terms of the Paris Agreement, and can increase market share and competitiveness and agglomeration effects. These are part of these wider economic benefits that we are talking about. So this is just a snapshot of the impact of transport investments. On the left-hand side, this is usually where we have the direct benefits and where we usually incorporate in our cost-benefit analysis. And on the right-hand side, that is where these wider economic benefits. And later, I'll show you some of the tools that are being used to be able to estimate, these three major benefits that are supposed to be generated when you invest in these transport projects. So transport investments, usually you see you have the generalized travel costs, which could result in user benefits, and then you have change in journey time, and and in between this direct and indirect benefits, because there would be some changes in proximity or location of household and firms that would result into this wider economic benefits. So just a definition, or how we how we can actually show what are these wider economic benefits. So sometimes we interchange it with what are these indirect benefits, because direct benefits are known to us. So indirect benefits, so these are impact on social welfare. So the norm that we do, as I've mentioned earlier, it's more of like we only kind of look into the cost of inputs and the benefits of the users in a project. So when in doing cost benefit analysis, as I've mentioned earlier, if you omit these wider economic benefits, it's because that there are no market failures. When you say no market failures, the examples of market failures would be information asymmetry for the economists in the room. There's monopoly, there's inefficiencies in production, etc. So when you incorporate this wider economic benefits in our analysis, we need to consider activities that will be displaced and putting resources has opportunity cost. So again, so this, when, in economics, all this, it comes to play. So opportunity cost would always be like, you need to see what would be, if you invest in a project, what would be the opportunity cost, and also if you're displacing something, there would be a cost also on that. And then, predicting and quantifying effects, especially for transformative projects. So, for wider, actually, when I think about it in the the literature, they're saying that, predicting and quantifying. So it's always a prediction. Although cost benefit analysis is similar in the sense that we have lots of assumptions, in doing wider economic benefit analysis, the prediction and the quantification may be more important for transformative projects, because you expect a lot of changes that will result because of the project. So measurement. So as I've mentioned earlier in the previous slide where there's a diagram. So there are three wider economic classification or category of wider economic benefits, and the measurement. So you need to measure of the real income gains. So this is what, if you have this analysis, what would be the real income gains? And there would be three mechanisms through which you can actually have the valuation for that. So there's improved productivity, increase in private investments, and job creation. If you can measure this and include this as part of our analysis, well and good. I don't think at this point we would have that in the current HDM4, right? We don't have, a way of actually, the results when we, in using HDM4 and we do the economic analysis and run it, you would have results on this. Okay, so when we say improve productivity, why do we have improved productivity? This is related to the clustering or proximity. So this agglomeration, cities clustering together. So why do, like, when there's transport, improvement, and it's easier to go into an area, and then there are firms that actually move into the area and they specialize, and then it becomes attractive also for other firms because of, it's the proximity. So in effect, there would be like you see cities growing, you would see, firms locating in an area. So you could actually measure the productivity gains of the clustering or the multiplication of these firms locating in an area. And then there would be increased private investments. This is more related in terms of when you see transport investments, and then there's residential development or commercial development. So, these investments go into an area where, the attractiveness of the place, given that, the accessibility that is being provided by transport investments. And then finally, job creation. So it affects both the demand and the supply. So, if for example, there's more jobs available, so people, and because of it's a cheaper way to go into the job where you don't spend a lot of money in terms of your transport costs, and doesn't eat up on the wage, then people try to re-enter, or the job participation rate increases. And then supply, depending on whether so this one you need to be cautious. If you get it from the other other sectors, then the net effect would not be as much. So just on the evaluation, so we have for direct benefits, we use cost benefit analysis. We have an Excel model. Our evaluators would construct Excel models on that. You have assumptions on demand, the assumptions on how the traffic would grow, on the unit values that you use for the main benefits of the project. And then the software application. So we use HDM4 for some of our projects. We also have this road economic decision model of the World Bank for these low volume roads. I don't see it as much being used in ADB, but in the past, this has been also used. And then for indirect benefits, so you have three methodologies: that reduced form equation, which is usually connected with the proximity agglomeration. A lot of literature has been done on that. So connecting the agglomeration with productivity. So it's a lot of studies out there on this input-output model. So there would be a multiplier that will be calculated, and that will be used to estimate what would be the impact on certain parameters. But usually what we see is these multipliers are kind of like very high in terms of the estimates. And then the spatial CGE's computable general equilibrium model, which is being used sometimes in projects. And later I'll show you just one quick project that has used the spatial CGE. So this is location-based, so you have information on where the transport investments are located. You need information on a lot of things: population, land use, where the firms are located, where the houses are located, etc. So benefits to be quantified. So you would see that here. Direct. I think everyone in the room knows more of this. Sorry. So just for people who are interested, so this is one project. Well, one in the Belt and Road Initiative. There are lots of types of transport projects that were considered under this study, and they did a spatial CGE. The paper was done by Anthony Venables and with some other colleagues, and one of them, we also, ATB has engaged to do some spatial modeling, spatial CGE modeling, but for real investment. So you would see here that because of these transport investments, what they wanted to do is to reduce the travel time in the economic corridor. So this is investments along certain a number of countries in Central Asia. You increase the trade also and increase income. So they run the model, and so the projects include upgrading road, ports, railways, pipelines, and other related infrastructure. So this is the methodology. They covered 7 countries, 3 sectors, and 52 geographic units. So you see the data involved in here. So they would assume that the changes in the travel costs due to these transport investments will stimulate production and consumption changes. And the results are as follows. So if you have limited supply flexibility, the increase in GDP per capita income is 1.9%. If you include as another scenario in labor mobility, productivity growth, agglomeration, 2.7%, and then you include trade facilitation at the border, it's 8.8% higher. So this is the country result. So you would see here the scenario with just the infrastructure improvement and infrastructure improvement with trade facilitation. You see the difference, and you see different results for the different countries that were involved. So it's the study actually presents these results, in that the details are in a paper. If you're interested, I can give you the link for that. Just shows you what this spatial CGE can model or estimate. So application, last slide. Application in ADB projects. So as of now, so it's not yet institutionalized, or I could say that these wider economic benefits are not usually included in the economic analysis of our projects, unless you can show that there are clear backward and forward linkages. Okay, so since we don't do it, we would ask our teams to provide a qualitative discussion, provide references or some evidences to support the project. At this point, CBA is actually, we can say that it's adequately providing us the information, and it's already a good approximation of the results. Of course, using using this models, this spatial CG input output, this reduced equation. Actually, if we can actually do that for our projects, well and good, because it actually strengthens our evaluation. But then, of course, we all have to note that incorporating this in our CBA could be challenging and has risk. So we need to actually think through on how, where we would want to put in resources in terms of doing that. And hopefully if our HDM, upgrade can actually incorporate that, well and good, then you don't really have to actually do a separate one, because currently we do it as a complementary analysis to support our evaluation. Thank you so much.
Now, Wena's with us for the rest of the morning and the session after morning tea. So if you want to ask her a lot of questions, we're doing group work after morning tea, and you can jump into her group and delve into things much more. Now, pleasure to invite Michael Anyala. I don't think I have to introduce him. He's been introduced so many times this week, but he is here to give us an update on HDM5. Michael.
Good morning, everybody. So basically, Martin Humphries should have been here updating, but he's not able to. So he sent his apologies. So I'll give you an update on what's happening with the development of HDM5. And then if you have any difficult questions, we'll forward it to the World Bank for them to deal with. So I'll go through just a brief introduction of what is the highway design maintenance standards model, is it's called, but that's just the overall name for all the HDM4 versions. Why there's a need to actually change, and then what's happening with the implementation of this change, the current status, and then the next steps. So the current versions of HDMMM is HDM4 version 2, which, as you know, was released around 2005. So this is coming to almost 20 years now. And then in terms of its application, it's been used widely at different levels, starting from policy analysis. So some of you could have used it for different policy analysis, for example, evaluating what's the appropriate design standards for the country, these kind of things. What's the impact of access road regulations in countries? And then in terms of its application, it's normally applied at these three levels. So strategic level analysis, where you can analyze the whole network to understand what's the budget requirements, and then be able to optimize that as well. And also for program analysis, so this would be, let's say a country would like to understand now what's the program of works do we need to deliver over the next 1 to 3 years. So you can use it to prepare a rolling works program as part of your asset management approach. And ADB does a lot of work with countries, particularly around this area, to try and embed HDM4 as part of the planning tool for governments. And then within ADB, we use it mostly for project level analysis, basically to assess the economic benefits of our projects. I can say probably more than 90% of all our road projects at the moment would use HDM4 for this purpose. And I think the same applies to the World Bank and most MDBs. So what is this HDM for? So essentially, if you build a road and you don't do anything, it will deteriorate. It get bad with time as a result of various factors, including traffic volumes, the type of the pavement that you've built, maintenance standards, so how you maintain it, as well as environment. So HDM4 will predict the performance of the road based on these particular factors. And then after that, it quantifies the benefits to society from savings in vehicle operating costs, saving in road agency costs, reduced travel times, decrease in road crashes, and environmental effects. And he applies this based on a life cycle approach, okay? So an analysis framework is still very sound, actually. And we continue to use it up to now, and it works well, but things have also been changing. So why really do we need to change? So many things. So in ADB, we know that the road management landscape has changed a lot over the last few years. So the way that the demands we're receiving from our client countries is now very different. Yeah. So how do we address climate change? How do you address climate resilience? Some of them want to move into area-based maintenance contracts. How do we make the case for those contracts? In ADB, most of our road investments at the moment are project investments. So we basically support countries in building roads and upgrading them. But as you heard from the previous years, the portfolio for transport has changed drastically. And what we're hearing from our clients is we now want to move to system management, asset management, okay? So we need the kind of tools that can justify this kind of investments in new areas. And that's why for us, we're very keen to support this. But then there are also many other factors. So technology has moved on. So the current HDM for technology is probably becoming obsolete. So that needs to be addressed. There's more computing power and so on. So many things have happened over the last 20 years. In addition to that, there's a need to understand better how to model pavement deteriorations and work effects. So I work quite a bit in Mongolia, and what we are seeing now is the implications of permafrost on the performance of roads. We've not seen this before, but our roads that we're building are failing as a result of that. But even existing infrastructure, so if you go to parts of Mongolia and you go into an hotel, look carefully at the walls. You start to see cracks already happening. This is because increasing temperature is allowing this permafrost to melt. And this happens to many things. So there are new materials that have come into play that were previously not being modeled in HDM4 before. We need to understand those. We need to model emissions better at all the various stages of emission modeling. And also road safety benefits needs to be quantified better. Not in the way that is being done. So there are many things that should be done. Wide economic benefits, which Rowena just spoke about, also needs to be considered. And during this period also, there's been a lot of work in this area. So we need to go back, understand what has been done, and then see how we can include those into the new model. So I'll now talk about how the change is being implemented. So there's a steering committee that has been established, and ADB is part of that steering committee. So we sit there, you can see Jimmy is behind there. So Jimmy is part of the steering committee, good timing. And the aim of the steering committee is basically to provide direction in HDM development. So we meet periodically. I think typically every quarter we should be meeting to discuss the developments. Now, membership of the committee at the moment is limited only to partners who are providing support directly or in kind to ADB. But I understand from the rest of the committee that other members are welcome. So if the organizations here who may be willing to provide this support, you're still welcome to participate. So at the moment, it's the World Bank, which chairs the committee. And then we have the UK FCDO, ADB, PEAC, EIB, and then African Development Bank is also coming on board, but they're yet to confirm. And then the World Bank basically have a project management team. So that's that one you can see up there, led by Martin. And then there's a team around it that is participating in managing the various activities that it's been developed. Then under that, there's a core technical team. And then there are various technical committees working on different particular aspects. I think some of the experts here are part of this. Okay, so that's the arrangement, and this work is ongoing. So just to give you a background of the progress now, in 2022, the UK government, through UK Aid, through FCDO, conducted a major research basically to understand what gaps exist. And then that resulted into a business plan for developing HDM5. And that has been the basis upon which we have started the commencement of development of HDM5. And then technical committees have been established and also scoping papers produced in various areas. So there are chairs of technical committees. I understand they have been identified already. For the Road Safety Technical Committee, a draft scoping paper is already available and is now with the core technical committee team to consider. So basically, these scoping papers will be produced, then they will be shared with a smaller group of core technical committee team, who will then look at these and advise on how these scoping papers could be implemented as equations into HDM4, okay? So I think the point here is also, if you have studies that you've done in this area, please share with us, and then this could be considered for including in HDM5. So the resilience work is being done by the Oxford University, so they're preparing the methodology for that with the support of the FCDO Climate Change Compatible Growth Program. And we'll have a meeting soon to discuss that progress. So in terms of the current status, so just to highlight on the IT architecture. So the aim is that this HDM5 will be a cloud-based system, okay? And there'll be a web-based interface where each individual user will be able to prepare your own particular project. But the aim is to then leverage a lot of the work that is being done elsewhere. So for example, link tools developed by others. So whether it is mission tools that have been developed, this could then be linked into that cloud-based system. And also can be able to draw on data that are being maintained by others. So OpenStreetMaps, digital elevation models. If we wanted to extract, let's say, gradient data, that could be drawn from there. Vehicle attributes, vehicle speeds, maybe from TomTom or Google. The idea is that, and I think this, if it works, would be very helpful, because one of the main challenges you've been having with HDM4 is normally the perception that it requires a lot of data, yeah, to deliver. But if you can leverage some of this data in a manner that can be used properly, then I think this is a good thing. And then also it'll allow for integration of different types of tools. So like the road safety tool being developed with the World Bank, so that could be integrated as well, and other tools. But in addition to that, we have to look at new models that needs to be delivered. For example, how do we model electric vehicles? So these are completely new concepts, and that work needs to be done, and that's also being done and will be integrated, okay? So my understanding is that the approach is probably the first version is intended to be released around 2005. And then other modules will be added as we go along. So we'll get something working that we can use, and then we continue updating as we go along. So I'm not going to spend too much time on these, but just to highlight that there'll be a consortium or a firm, IAD, to develop this IT architecture on a design, build, operate, transfer basis. So what we need to do is to transfer the IP rights to them so that they can actually do the development. And then when we started to look at, is there an existing IP rights for HDM4, we could not actually find any because it probably lost in the record somewhere. So some legal work is being done where the legal experts will go back to the people who funded HDM4 before and say, can you write off the rights and say, give it to the World Bank. And then the World Bank will then create a proper legal document, and then the World Bank will transfer that to the new concessionaire. So there's a lot of activities going on to actually support this. I'm not going to go through all this in detail. So like I mentioned, this business plan has already been developed before, core technical team has been published. So these activities are going on. In terms of current progress, a lot of studies, meta-analysis studies are going on. So the World Bank have done a few that have already been published. ADB, myself and Rowena actually should be starting to work on some, together to produce this meta-analysis, which will actually support the wider economic benefits inputs into HDM4. So in terms of next steps, so there are also works that are ongoing or under procurement to do a number of gap analysis in deterioration, user works effects, partial review of the software itself, and also the terms of reference for the architecture has already been produced. I think it's now in EOI stage for the firm that will actually design the IT architecture that I showed earlier. And I just want to mention particularly for that, because that was probably the most difficult aspect to do from a funding aspect. We required substantial amount of funding to get that going. So the government of Japan stepped in, and they will fund most of the IT architecture design so that we can actually move on. So that was good. So that was particularly the main activity that delayed our development according to the regional program. Okay, so I won't go through that. I'll stop there. But just to mention that there's also a website that you can go to. But if you have questions, you can share it with me, and I'll try and find answers, whether from the World Bank or from others, so that we can get feedback to you, okay? So I just wanted to give you an update on what's going on and let you know that HDM5 is coming. You can still use HDM4 perfectly well, yeah? It should not stop you from doing that. Thanks.
Yeah, there's a few of us, I think, around the room and online that are involved in some of those studies. So my original work was on the vehicle fuel emissions and fuel consumption vehicle emission modeling. And so I'm updating that at the moment for one of the projects. It's now my privilege to invite Professor Corelli, former professor. Is it, what do you call it? Do you still retain the professor?
That doesn't matter.
To the stage. So as I said earlier, has been involved with HDM4 for many, many decades. And is after the University of Birmingham, then went to the World Bank, ended up there for a couple of decades and was a country manager there. So his experience from the research through to the implementation, through to the managing projects. And he's here to delve more into HDM5 for us. So Henry, please.
Thank you very much, Ian, and good morning, everyone. My presentation will be very much building on what Michael and Rowena mentioned earlier. It's really to look at the scope of HDM5 and also to engage with you on what are the priorities from the perspective of the Asia and the Pacific countries. What should be the priorities of development for HDM5 going forward? First of all, let's look at the proposed enhancements. As I said, we'll be drilling deeper into what Michael has mentioned. The main areas are the software and IT environment, at least proposed areas of enhancement. It doesn't mean it's now cast in stone. It's more a work in progress. We'll also be looking at the analytical framework, some of what Rowena mentioned, the wider economic benefits, how can they be incorporated in HDM5, and vice versa. How can HDM5 link with the tools that are used for wider economic benefit analysis, the CGE models, and so on? How can there be transfer of data between HDM5 and these other types of models? Michael mentioned the need to update technical models that are built into HDM4 and carried forward into HDM5. What upgrades or what new systems are needed in these? And of course, beyond the existing models within HDM4, what are the enhanced capabilities that are required to bring HDM4 into the current world? And climate change, of course, we've been talking about this, is an obvious one, even before it's mentioned. Starting with the software and IT environment, Michael already mentioned a cloud-based system. There is more to cloud-based because many of our developing member countries, DMCs, some of them at least, may not have efficient IT connections, internet connections. And so the cloud-based system must be able to cope in environments where countries have a less efficient internet connection. And so you'll see on that slide, it says cloud-based, but also offline. If you look at, many of you probably use Microsoft Office package. You use the Microsoft cloud-based storage, and you will know that you can actually work on your laptop or desktop or whatever, even your tablets, iPads, offline, and at some point it will sync with the cloud. So that's the architecture that is being thought about, that will cater for situations where the IT network is not as strong, or the internet is not as strong, but you're able to sync and keep your data up to date. Cloud-based also means easier and better management of the software system itself. At the moment, HDM4, if you need to update it, you probably have a disk sent out, or better now, you can still download it and then reinstall and so on and so forth. But with the cloud-based management, all of that is done just like your Microsoft Word or your PowerPoint, any of the Office-based systems. I'm using that not because I work for Microsoft, but I know most people use the Microsoft package, and therefore you're familiar with how it works. The upgrade to your Microsoft Word is done without you probably knowing. You'll get a notice that it has been updated. So that's the kind of system that is envisaged. And then, of course, allowing users to be able to store their data on the cloud, meaning there is collaboration. It's not just one person who is permanently using the system and it's locked with their password. You can't get access to it. So you can have, you can configure it so a whole office or department can share data, and you can also share data from a country, from one country to the next. Calibration, for example. Pacific countries, if we do the calibration of HDM5 for one of the Pacific countries, it should be able to be shared amongst all the other countries because the environment is similar. It's not the same, it's similar. And then you can fine tune it. Improved end user reporting, in particular, the HDM4, those of you who've used it will know that the reports are rather limited and they are sometimes difficult to interpret. So here is an environment where you can actually get much better management reports customized to the leadership of an organization. For example, if you do a network analysis, it's much easier for the head of the road administration or road agency to understand what HDM is saying. At the moment, it needs an expert to maybe export the data to Excel, then do some charts and so on, and be able to engage with the head of the road agency. That sort of thing should be done so that you have customized management systems. And then on the IT side as well, integration with road asset management systems. It takes quite a bit of technical ability at the moment to integrate HDM4 with road asset management systems. And I guess people like Ian, you've made quite a good living out of it, right? So it doesn't mean it's going to stop. Myself included, all right? So, but the whole point is to make the HDM5 database accessible and use a common tool that at the moment, HDM5 uses a very complex and proprietary database that is very difficult to access. In fact, probably impossible to access. So you have to develop design systems that will export data from one to the other. And finally, the application performance interfaces, APIs, will be made available so you don't have to develop your own road deterioration models or vehicle operating cost models. You can actually plug the HDM5 modules into your own road asset management systems without necessarily using all of the HDM5 system. The next one is the analytical framework. Whilst Michael said, and Rowena as well, that the analytical framework, the CBA, cost-benefit analysis framework, is sound, it needs to be extended, partly to look at wider economic benefits, but also to be able to do some of the other standard economic analysis type of activities, sensitivity analysis, for example, scenario analysis. All of these can be done with HDM4, but it needs manual intervention to do it. So if you can build that in, so it's done quickly, it's fine. One other improvement here is multi-criteria analysis. At the moment, it's not done within HDM4. You have to export the results to a spreadsheet. An MCA, multi-criteria analysis, is really taking into account the broader or wider economic benefits and being able to look at cost benefits, the economic analysis benefits as one input to a wider decision-making framework. So emissions, for example, if you don't want to put cost to emissions, then you can compare economic benefits, the emissions reductions, and other social impacts, and decide what are the weightings between those three, if there's only three, and using that to prioritize what your projects or network interventions should look like. Calibration, big issue. Calibration of the data that is used to adjust the performance of the HDM4 models has been quite an issue. So we could have, for example, calibration data sets. So if I have a calibration data set, all I need to do is to change one or two things, and the rest of it is ready-made for you to import. One other one I should mention, calibration exogenous inputs, for example, road closures. One of the working sessions will be looking at the impact of road closures and how that can be done. So all of these could now be incorporated in HDM5. The updates to technical models, probably the most obvious ones, really. The pavement deterioration works effects. There are new materials. There are new equipment. There is, of course, the changing climate that's impacting the performance of how roads work, new maintenance techniques, new maintenance materials, and so on. So all of these technical models, as we call them, will need to be looked at. One area that will need to be expanded is vehicle fleets. I think Rowena and Michael already mentioned the need to incorporate electric vehicles, which have a completely different performance, obviously zero emissions, but there are other types of vehicles and fleets that need to be incorporated. Diverted traffic, for example, needs a network level analysis as opposed to single roads to be on it. And then finally, the enhanced capabilities. We talked about climate change impacts. There is consideration of low volume roads. At the moment, it's done using the RED model, as Rowena mentioned, but there is no reason why it can't be done in HDM5 because the CBA framework is the same. So it's really how do you fine tune that into one tool that can cope with different types of roads that you're analyzing. Asset valuation, been talked a lot, many years, decades, but has never been incorporated in HDM. And so there is the thought that it could be done. Again, all the data is already in the system, your pavement characteristics, your construction costs, and so on. So there's absolutely no reason why you can't include asset valuation in there. So these are some of the things that are coming up. So we will be discussing. There is a questionnaire which will be issued later. I think Ian will give that probably at the end of the sessions, which we would like to know from the Asia and the Pacific point of view, what should HDM5 include? And what are the priorities that you think there are for Asia and the Pacific countries? So the questionnaire will be trying to elicit from you, your perspective. You may not be an expert on HDM, but you're a practitioner. So from the practitioner's point of view, maybe if you know HDM4, what is missing? If you don't know HDM4, it doesn't matter. What would you like to see in HDM5? So I'll stop there, and the questionnaire will be issued later on. Thank you very much.
Yeah, so we'll there is a questionnaire. We'll be giving that out and leave it with you to work on, because when we're having some group discussions, you're welcome to explore any of the subjects with any of the people that are around. You can, Michael, Henry, Rowena, myself, a number of others here, George, are all very familiar with using HDM. So if you've got any questions, and we'll go from there. Next, it'll be next. We should have Alexandra online. So Alexandra Spurnell, there she is, coming up. I can see her on one screen. Hopefully, will come on to the next soon. So, unfortunately, due to situations, she isn't able to be here in person. She did speak the other day at the climate resilience transport session, was it? Certainly the other day. Anyways, Alexandra's over 30 years of international experience across the transport sector, significant usage of HDM4 as well included in that. So this is the start of a two-speaker session on HDM4 and climate resilience and modelling. Just so you know, we're going to push the second one, tea and sending, until after the tea break. Alexandra, it's at what, 3 in the morning for her, so we will have her speak, then we'll do some Q&A to her, and then we'll let her get to bed. So, Alexandra, please, the floor is yours.
Yes, is it okay if I will share my presentation, because I made some last-minute changes when I noticed that I would not be in Manila with you. I'm very sorry for this. So I hope you can see my presentation also.
Yes, we just need you to go to full screen if you could.
Yeah, I'm doing this now.
Or presentation screen, whatever you'd like to call that.
Yes, but the slideshow is hidden. Here we go. Yes, you can see Perfect. It. Thank you very much.
Thank you.
So, as Ian said, I'm well, 30 years, also very old acquaintance of HDM4, but I'm more a practitioner. I'm a consultant. I'm doing HDM both for the network analysis, for the policy developments, and also for the project analysis. And obviously, climate change comes up all the time as an issue. And there are some things we can do with HDM4 and some things we cannot do with HDM4. So I wanted to give you some hints of what can be done for those who are already practitioners. And maybe it will also give you some ideas on what would you like to see in the future HDM5. So I think, first of all, we have to be aware that HDM4 is a pavement model. We are modeling pavement deterioration and then the effects on this deterioration on the vehicle speeds and the vehicle operating costs. That means that, generally speaking, we are modeling deterioration over time, and we do not model sudden events. So we do not model disruptions. This is something we cannot do. The second thing which we cannot do, because it wasn't included in the HDM4, and I'm advocating strongly to include it into HDM4, is that we cannot very well model the absence of routine maintenance. For example, drainage works are essential in terms of climate resilience, climate adaptation. We all know that the absence of drainage and routine maintenance will affect your pavement life. How to reflect this in HDM4 is now, these days, not really straightforward. I made some small modeling and preparation of this workshop. And obviously, if we look at climate change, the idea we would have is that we would have higher rainfalls in the first place, higher temperatures probably, and then probably higher intensity of rainfall. So for gravel roads, higher rainfalls should immediately lead to higher deterioration with higher gravel wear. Gravel goes out more quickly. And especially this would affect steep slopes. I think if you are from Southeast Asia, South Asia, and even in Central Asia, you would see that there's a tendency to try to pave gravel roads, especially the steep slopes, as they cannot withhold anymore the very high rainfalls. So interestingly, if you just change the rainfall in HDM4, it will not change any results. So for asphalt roads, the situation is a little bit different. We have a lot of different calibration factors which we can play with, and we can always push roughness deterioration. So roughness is basically the main driver in HDM4. We have many ways to accelerate roughness in the model to reflect our knowledge of road deterioration, meaning that anybody who uses it should have an idea already. If previously without climate change, my surface treatment was lasting 10 years, now with the higher rain, maybe it will only last 7 years. Based on this, I can try to calibrate to reflect this shorter life. Also, the bearing capacity is one of the big factors which would be affected by climate change. If the roads are inside the water for a long time, this is the case of floodplains. Obviously, the bearing capacity is weak for a longer time. Obviously, we have pavements washed out by flash floods, which we again cannot model. What we can model is that they are weak, that they will fail due to low bearing capacity. And then again, it brings up the policy dialogue. In Africa, for example, the rain barriers were very popular in the 60s. Then people considered that we cannot use them anymore. We have 360 days access. And now rain barriers become popular again. When the pavements are soaked, we just close them off for 1 month, leave them to dry, and it actually substantially increases their life. So I made, so these are proposals for modeling of the climate change and the pavement deterioration. As you know, we have roughness deterioration in a curve, which you can see here. The current HDM curve is the blue curve, and with extreme climate, obviously our deterioration will be faster. So what we would add, we would still have roughness due to structural condition, roughness due to cracking, roughness due to rutting, roughness due to potholing. But we would include additional factors to model more closely the rainfall and to model more closely the heat. And that would overall accelerate the deterioration over time. So I said I made some models. So like Henry said, the reporting in HDM might not be that good, but if you are good in Access and in Excel, you can still see it. So for gravel roads, let's have a look at this graph. You have roughness progression with different parameters. My base case, just an average gravel road with about 300 vehicles a day. I model my roughness in the blue curve. That's the normal one. With the normal environment, no calibration factors. It goes as it goes. If I increase the rainfall, that's the interesting thing. What's happening is that we don't get that much roughness. So not sure where this comes from in the model, but increased rainfall doesn't have a bad impact currently on gravel roads. So this is part of the models we have to update. But we can increase the calibration factor for roughness deterioration on gravel roads. So I tried this one. This is the gray curve. So you can see that here, my roughness goes faster. And every time, of course, we go back, that is when I do regraveling and grading. So it means here, if you look at the gray one, the deterioration is much faster and the number of interventions you have to do on the gravel is much higher. Sorry. And the last one is to look at the gradient, because gravel roads, especially on steep slopes, as I said, are very sensitive. So if I take my average road and I just increase the slope, even though it's the same road, then you can see that it doesn't increase the roughness progression as fast as we would imagine it. And it overall has the same intervention times, but it would require more intervention to keep the same quality. On the right side, you see it on asphalt. So asphalt roads are generally more protected against climate change. That's why countries like Cambodia have a policy to pave gravel roads, which takes a lot of their budget, but which is probably a good move in terms of protecting the roads against the heavy rainfalls. So we have here my base curve, which is the blue one, which you cannot even see, because then I increase the rainfall and you see that it's exactly the same. So asphalt roads are currently in HDM absolutely not sensitive to the rainfall. But then again, I can increase here, I reduce the structural number, means the bearing capacity. The problem with this is I can do it only once. So if I reduce the bearing capacity because my road is all wet, then you can see that roughness increased from 4 to 10 in over 5 years instead than 10 years. So that's almost what we want to have. But when I come in with my first maintenance, then of course, HDM models it again as a strong road, and off I go. And I cannot currently ask HDM again to give me a wet road. So that's one solution. The other solution is just to play with calibration factors. I did it on this one on the yellow curve. And you can actually adjust your pavement life to what you expect. So that would require either to have historical data in your country or to have experienced local engineers who have a good knowledge on the current behavior of pavements under the rainfall, under the increased rainfall and under the climate change. And I think Töns is going to go in more details on this. Now, the biggest economic impacts actually on this climate change currently are disruptions on travel time. And these have social and economic impacts, of course. The picture I put you here is actually a photo from the Balkans, Southeast Europe, which is a bridge which is flooded every year. So you have these recurrent flooding and recurrent closures, which is one thing. Your bridge is closed for 3 days every year, or you can have landslide, which will cut off, but they are cleaned very quickly. And actually, traffic would probably go home, stay there, but not necessarily use a detour. And then you have the failure. Well, that is the washout in case of flash floods for pavements. It's bridges where the piers are failing under the high water. And these disruptions require to implement a detour. The problem is, of course, that we have to have a probabilistic approach. We don't know when these failures are going to happen. We don't even know if they are going to happen. So we have to look at the likelihood of an event. We have to look at the vulnerability. That means how much will this affect the people around? What are the repair options? How long they will take? And this would be applied to every single event. It can be a bridge failure, it can be landslide, mud flows, avalanches, washouts. The principle is that you stop your road not for 1 hour, 2 hours, or 1 day or 2 days, but for serious time, the time to make emergency repair, and people would be asked to use a detour. And this detour can be more or less long. In HDM, you can model only the VOC, the roughness, and the time cost. So if I look at the bridge, which we see here, it's actually not easy to model with HDM because it's 1 kilometer. So 1 kilometer is generating limited travel time and limited VOC costs. But if I have a detour, then of course, the travel time will explode, the VOC will explode, but there's another thing which will explode, which are the greenhouse gas emissions. And these things I currently try to model outside of HDM, then bring these delayed costs back into HDM or back into an economic analysis spreadsheet. So this, in case of failures, the road will be unpassable for a short time. We don't imagine that countries would leave, even poor countries like Laos have emergency response. Nobody would leave, especially if the road is a national road, people completely disconnected for a long time. So the short time is usually for light vehicles. You can put in place a very detour in 1 or 2 days. If you have heavy vehicles, then to reinstate passability will be a little bit longer. Most of the time we implement the Bailey Bridge or something like this. And eventually you will continue to have load restrictions or speed restrictions for a long time, the time to reconstruct, the time to clear fully. And that for a bridge, it can take up to 18 months. And then I come back to the flooding and the delay cost. For regular flooding and regular closures, which are happening every year, this is just delay cost and waiting costs. The interesting thing is that these costs are so high that they basically will justify all climate improvements. This is, again, my famous bridge, which you see, which is located, so this is the Adriatic coast on the Mediterranean Sea. My little bridge is the red point. It is on a national road which goes to Greece. If you want to use this road and this bridge is closed, then you have to actually start your detour about here to go into Greece on the south side, or you would start from here, depending where you're coming, and you go on the other side. The total detour, including the different border crossing restrictions, is about 210 kilometers. On this road, the traffic in 2020 was substantial. We are talking about 7,000 vehicles a day. We are talking about substantial truck traffic. And if we just close it for 1 day, we have a GHG cost about $18,000 compared to $80 when you just cross the bridge for this 1 kilometer. Even if we compare it to 40 kilometers, which would be the section where you take the detour and after, it is marginal. But the GHG emissions in the detour scenario are absolutely huge. So for this bridge, the reconstruction cost, investment cost would be about 1.5 million. And it's compared to $120,000 for 1 hour waiting time with this traffic. This is cargo delay and it's working time and non-working time of passengers. So $120,000 for 1 hour, you can see that even in 1 day, you have already recovered your investment. So I've tested this on many, many cases. And of course, if you have a rural road with a village of 20 people and 3 motorbikes, it wouldn't work anymore. But it would work on probably 90% of the infrastructure we are now managing in many countries. and which we would model typically with HDM. So even without an improved HDM5, this is my small conclusion, the climate effects which are affecting the deterioration over time can be taken into account. If you're good in HDM, you can, I call it fiddling around, but you can say adapt it, calibrate it, that your climate effects over time can be taken into account, and we should do this. But the disruptions, we cannot do it anymore inside HDM, but we can do it outside of HDM. As I said, it's a very important economic cost. It would justify most intervention. And the way of doing it is to model your road normally with HDM, then model the detour with HDM, include these, and then compare basically the economic costs and benefits of this option, including the reconstruction or not reconstruction. And where the probabilistic thing comes in is that I can model the failure in year 1, in year 2, in year 3. And I can even say my failure is only 50%, so I would take only 50% of these benefits. And I can tell you that it still would work. And climate resilient, you can still model and justify climate resilient investments in this way. Thank you. And I will give over to Teuns. Ah, no, you said that you will do it after the break, right? Okay.
Yes, yes. Hopefully, first of all, thank you.
Thank you. Sorry for not being in Manila, but that's the best.
That's okay.
Thank you.
So Alexandra can get back to bed before we have to talk to her later in the day. Are there questions for her before we go for the break? There's some microphones around if anyone's got a question there. Yep, Georgie, just grab the microphone.
Is it on?
Yep.
Can you hear? Okay. I think I put some questions in the app, but I think I can do it from here also.
Put it on the screen.
Should I read questions?
Can you hear that, Alexandra? Yep,
yes, I can hear fine.
She can hear, yeah? Okay, thanks.
Yes, yes.
So I have one question in the app. So we discussed these delay costs because they are usually easy to estimate because we have existing detour. We can calculate the operating cost and just subtract. But what happens, for example, if there is no any detour? And of course, not all detours can actually be considered detours because if, for instance, it takes 10 times longer, I mean, somebody could absolutely choose different transport. I mean, it could be economically to use even helicopters if it's an emergency. So it's not really fair to compare that detour would be used in practice. I mean, so my question is, what are the options for the waiting cost? Basically trips that could potentially happen, but don't happen now. So how we will deal with those? Thank you.
Yes, that is a very interesting question. Actually, it's almost a question for Rowena because it's going into wider economic benefits. We can model very easily the delay cost or the waiting time. So what happens, in my opinion, is that actually very little trips are cancelled. As I said, on rural roads, we cancel the trips, but it has economic impact. And in rural roads projects, usually we do not use HDM. We use more multi-criteria and more other economic models, but we have this last mile connectivity principle. That means that the income of the village, because they cannot go to the market and sell the rice, then sorry, the household income will drop. And that is, again, something you can model outside of HDM and then return into your full economic analysis. That is the main impact for rural areas when the trip doesn't happen at all. So it is economic loss, and we can model this also. But on national roads, which are the ones which are most commonly modeled with HDM4, my observation, especially well in the Balkan and also in the Caucasus and in Central Asia, is that people will look for a detour, and also emergency response is relatively good. So people will wait and cancel their trip for a few days you can use these economic effects, but they will be minor. But they will try to have a small detour and a passage, at least for light vehicles and light good vehicles. The ones which are really affected are the trucks, because they usually cannot. And if there are no detour, these trucks, they go to light vehicles. And that is a very high transport cost for goods. So that's the way I model it. But I think it's a bit particular. Everybody does it its own way because we don't have a fixed software to do it. Yeah.
Okay. Anyone else got a question there? You are welcome to use the app. I will look at the app as well, but if you've got a question, or Weena, did you want to add in around that issue of? Oh, you've got a question. Okay.
Sorry. Hi, Alexandra. Good morning.
Yes, good
morning to you. I have a question on the modeling that you did on the gravel and the asphalt. It seems that for asphalt, if it's asphalt, then not much would have, it doesn't have the same results if in gravel when you incorporate this climate events, right? I wonder because okay, I don't want to like insinuate anything, but like it also even if it doesn't really affect asphalt that much, but then it's the quality also of I don't know, does it matter that the quality of the asphalt is taken into consideration? Because the assumption in HDM4 when you say this is like the road is asphalt, the standards are being met. But then, when you go into actual construction, the quality there is, of course, sorry, the construction quality factors into that. So it can actually even if it paints a better picture, right? But, that one doesn't, how does it, should it be taken into account? Yeah,
well,
that's
of
a
course,
question.
first of all, of course, we should take into account the actual, let's say, substandard quality, which we see everywhere and which we fight against all the time. I think it's a question which is different from the climate change. We, in any case, have to have a quality construction, and that is a challenge everywhere all the time. Overall, I was actually before a big, let's say, fan of gravel roads for rural areas because they're easy to maintain, they're easy to construct. If we look at investment costs, let's say even 5 years ago, rehabilitation of a gravel road would take you $50,000 per kilometer, and bituminous road 100,000. But we see that with the rainfall we have, the gravel is washed out, even if you make quality gravel surfaces. If they are on steep slopes in mountainous regions, they just don't hold. So we started making mixed roads. That means we do gravel in the flat sections and we do DBST in the little slopes, and we use concrete in the steep slopes. And I think that is a standard which has been used by many people in many countries these days. And the more you extend, actually, the more you go from these mixed roads to asphalt roads or concrete roads in flat plains to try to make a construction which will last. If then, of course, you go in with good engineering solutions, but in the field there is no supervision and the quality is bad, then that's all ruined immediately. And this quality thing you can actually factor in HDM. As I said, the deterioration curves you can adapt to what you see. The fact that we are still constructing roads which are ruined in 3 years, and we are in 2024, I find it actually quite sad. We have enough experience, we know exactly how to do it, and we cannot manage because of, let's say, human factors in many countries. That's not acceptable first. And it is worse with climate change because the solicitations are higher and the effect of bad quality shows up much quicker. I've seen it in many countries. I'm not sure if it answers your questions, but we should always take into account the quality we expect when we make the model in the first place. Or when you make the ex post evaluations, you will see that you were over optimistic and you actually don't get the same economic results which you did at project preparation. And that's also not good.
I think we've got time for one more. If anyone else has got a question. Otherwise, I'll just, oh yes, one question down here. Sergey. Been on.
Hi, Alexandra. You mentioned the fiddling about with HDM4, and I think the same goes for other models like RED and RUC model, for instance. Now, for you doing that, that is not really a problem because you're well versed with HDM4 and you're a road engineer yourself, so you know when the fiddling about is providing a realistic picture or not. However, HDM4 is a tool that we would assume is widely used by different member countries and different engineers and economic modelers in those member countries. And that's where I see a lot of problems occurring. That I've worked a lot with local staff who are using HDM4 or one of the other models. They also tend to fiddle about because you have to fiddle about to make it fit. But their fiddling about doesn't always give you a realistic picture. It gives you a nice outcome that is positive for their results. But I'm not really sure what my question is, but it's about the difficulty
in safeguarding, right? It's about safeguarding the data input and output, right? Garbage in, garbage out.
Well, the problem is in HDM4, you need to put in a lot of data and you need to do a lot of fiddling about to make it realistic. And because you have to do, as a user, you have to do a lot of the fiddling about yourself, it means it's very subjective in the end, or it can become very subjective in the end. Either you use the default values, which are not correct, or you do fiddling about, which may not be correct. So in the end, you need somebody well-versed in HDM4 on the economic side and the engineering side to make sure that it works properly.
Can I jump in?
And how can you ensure, maybe in HDM5, how can you ensure that there is more safeguards there, that whatever comes out is a bit more based on reality?
But was it John Hine who used to have a slide that said, with HDM4, the answer you want is the answer you can get?
Yes.
Because of the fact there's so many calibration. I think it was but it is an issue that the model itself, in my view, it's looking for the long-term wear and tear type damage of a road. So it doesn't deal well with these spike events, whether it's a flood event, whether it's especially on a rural road, if you've suddenly got, say, a timber plot being forest being milled, and this road gets hammered for 6 months, and at the end of the 6 months it's completely destroyed. But if you model it in HDM goes no different, because it goes over the life of a road that's had no real impact. But yeah, so it doesn't, in my view, at the moment, deal well with these shock events or whatever you wish to call them. But Henry's got the microphone, and I think that means he's going to give us the words of wisdom.
No, just to help out Alexandra here. I think what Serge is talking about is the calibration. Yes. And there is quite extensive write-up in the HDM4 manuals about how to do calibration, and there are different levels of calibration. And you're absolutely right. If you don't calibrate it properly, then garbage in, garbage out is the answer. But in HDM5, the proposal is to actually control the calibration better and to have the calibration sets. But you will still need somebody with expertise to do that calibration. So
I wanted also to, sorry, we have some time difference. I also wanted to say that when I started using HDM4, it was always recommended to me that HDM4 should be used by a team, and it should be used by a transport economist, a local engineer, and a HDM4 engineer or specialist. You need the local knowledge, especially if you don't have so many data on calibration, but you also need the expertise to say, we're not going too far, in this calibration. So, sorry, Henry, back to you.
I think you've done well. I think we'll let you get back to bed. Thank you. And it's looking beautiful. Yep. Okay. if we can take our seats. Don't take them outside, but just take a seat. Okay, welcome back. So the next speaker is a very good friend of mine, Tiens Henning, Associate Professor Tiens Henning, Deputy Head of the Civil and Resource Engineering Department at the University of Auckland. He's also the head of the Climate Adaptation Platform and is the second part of our two-part speakers on the climate change use of HDM, so following on from the work of Alexandra. So Tiens, the floor is all yours.
Thank you for the introduction, Ian, and thank you again for the opportunity. I have been speaking earlier this week, so I'm going to get straight into it. So as Ian has introduced, my topic area is the second part to Alexandra's fantastic presentation on using HDM4 or 5 in the future for modeling the impacts of climate change. So just maybe to set the scene and the context to my presentation, I think that Alexandra has made the point already that we have got the two sides of climate impacts, the shock events, and we see quite a few nice illustration of shock events impacts on the left-hand side. But really what we're more interested in from a pavement deterioration perspective is what I term the slow burning changes, and that would be accelerated deterioration to either higher or lower temperatures. There could be secondary impacts from land use changes, sea level rise, and often what we sort of underestimate is the impact of contrasting climates between your wet and dry cycles or your hot and freezing conditions. There's definitely a place for HDM in looking at the impacts of shock events, but what we often find from a financing perspective that shock events would be covered under emergency funds, whereas the changes that's happening slowly over time is often not necessarily catered for in any specific financial instruments. So that is why that is so important. So what I'll be talking about are the typical pavement issues that may occur as a result of climate impacts, increased potholes, rutting, cracking, with cracking in particularly the freeze-thaw actions, and then the raveling or the chip loss of surfaces. Now, one thing that came out in the previous session that was quite a good discussion is that the climate is just one of the impacts. We also get many countries in Southeast Asia that's faced with poor material quality, in some cases poor construction quality, extreme heavy vehicle loading. I have to say that I've done some work with Ian in Indonesia, and there we were really astonished by the vehicle overloading problem they're struggling with, lack of maintenance, and then on top of that, the climate. So we need to incorporate some of these thinking when we get to the modeling side of things. So one of the first steps that I would really encourage you to do is to stand back and really think, number one, what are the issue you're concerned about? Which part of the pavement is that going to impact, and then how you're going to model them? In this figure, I've got 3 examples of typically where we can use the HDM4 type models, or hopefully even HDM5 moving forward. The first group is understanding the impact of climate on our existing pavements. Now, depending on what's the issue is, the climate issue that we're mostly concerned about, it may impact different parts, of course. So normally your temperature-related items would mostly impact on your road surface, asphalt in particular. where increased moisture condition and freeze-thaw actions may then be more of a concern within the pavement itself. Typically, the type of analysis we would do to understand those impacts has been covered in Alexandra's presentation, so I'm not going to dwell on that again. There are two other types of analysis that I would like to discuss. The first one is, although we don't necessarily look at modeling the impact of the shock events, what we have seen in many countries is that due to a shock event, your main route may become impassable or closed. We then get our vehicles being detoured onto local roads, sometimes low volume roads, even unsealed roads. And of course, those roads are not designed to carry that sort of traffic, and they go into rapid deterioration. So certainly for many countries, this is sometimes the biggest issue. Now, the interesting thing that we found, in particular with the recent events, last year events in New Zealand, is most of the emergency funding only cover you for direct impacts of weather events. So that would pay for, say, the state highway that's been destroyed, but it doesn't pay for secondary impacts, so the impacts of the increased traffic on local roads. So that is often quite a difficult one, and therefore this type of analysis comes in very handy to model those sort of impacts. We can also, in some of the examples that I will show you, can use these types of model to understand the impacts and resilience improvements that we can make. And that's a very important question to answer, because often we have to look at the life cycle costing associated with using alternative material solutions. Now, the moment you do something outside of the norm, it's going to cost you more money. But that initial cost investment may actually, on the long run, save you quite a bit of money. And this is ideally the types of questions that HDM can help you to answer. I'm just going to take this figure that I've talked to a little bit further. And this is, again, looking at understanding the part of the pavement that you are investigating. So what I have shown here is the colored blocks, the orange blocks being all the models that's to do with the surfacing. And the white blocks are normally the ones that's more to do with the pavement models. And as HDM currently stands, most of the surface impacts feeds into the pavement deterioration models. So I think that's a very sound way of modeling the ongoing impacts. And we don't know that as a road engineer. If my surface is starting to fail, it won't take that long before I will see increasing pothole, increasing rutting and roughness. So just keep in mind this particular figure when you do this type of analysis. The biggest problem we have is we often don't have the data to do this type of analysis. And I was involved with a study that looked at alternative surfacing solutions, in particular the epoxy mixes into asphalt and chip seal surfaces. And for that, we had no data, virtually no data. We did have a bit of laboratory data, but apart from that, no other data to inform our models. So for this HVT research, we have then looked at how we can harness different pieces of data to help us with the modeling process. What we have done was using the long-term pavement performance sites in New Zealand and using laboratory results to adjust some of the outcomes on the New Zealand trials. And then we've extrapolated that for the application. In this case, we've looked at a case study in Africa. So by combining laboratory results and some field trials, and we were also fortunate in New Zealand to have the accelerated pavement testing results, we were then able to calibrate and to use the models in our impact assessment. And this is just one of the outputs that was delivered out of that particular study, where you've got on the left-hand side your control sections or your standard bitumen sections. In this case, we've got an asphalt surfacing on a relatively strong pavement and with quite high traffic, and we can see the result that came as a result of using the alternative materials. Just a few words that I would like to also raise with the alternative materials is there is no wonder solution that's going to solve all your problems. I think that in particular, I would advise you to look at the Road Note 31, where we've looked at all the different solutions in different climate conditions. So if you've got a colder climate and you're mostly concerned about cracking, you're probably going to use something quite different to the solution that you need in areas where you've got a significant heat increase. So there's different types of technologies for different solutions. And then you need to use the HDM type analysis to give you a good outcome on understanding the long-term cost impacts of using the different solutions. So that earlier work that I was referencing, that report is also available. You're going to have the slides. I've included the links of these reports so that you can go and look at it in a little bit more detail. Also, last year we had in the Transport Forum a good presentation on the Road Note 31. If you've got access to that, I encourage you to also go and look at that presentation. Yeah, so for the moment, I'm going to just stop there, Ian, and I'm happy to take any questions.
Thanks, Tiens. Are there questions for Tiens at this stage? Because otherwise we're going to let him go as well. Yep. Microphones where? If we can... Oh, right beside. Who would have thought?
Hi, Tiens. I'm Neil Ebenezer from HVT. So thank you very much for the shout out of the projects that we had helped fund, like Chris and Road Note 31. And I've actually got some cards with a URL to the HVT website for people who want to download those documents that you've mentioned. But the question I had about load was really around when we're looking to the future, we're going to see EV trucks coming on to a greater extent. Now, the load characteristics, because of those electric batteries, is going to be significantly higher than an ICE truck. We also look at then you get connected vehicles where these are going to run in convoys. So you start looking at that load on one side of the road, rutting, the wear characteristics that you mentioned. And I just wondered how the modeling could take account of that.
Very good observation. Thank you for that. Just a comment on the EV type vehicles, you're absolutely correct. And in particular, I don't know the situation around the rest of the world, but we've got these new double-decker buses in New Zealand that's electrically driven. And they are, number one, significantly heavier. And then, unfortunately, the wheel configuration hasn't been adjusted appropriately. So the impact load is significantly higher to other vehicles. We've done a few studies for some cities in the country, and we've got in some places a 30 to 40% increase in damage due to that vehicle type. So yes, we need to be aware of it, and yes, we need to be aware, be able to model those impacts. You're absolutely right. With the automated driving systems and where you get the channeling of vehicles driving in one place all the time, that is also a significant impact. I think for those of you who's in the asphalt area, we've got a shift factor of testing asphalt, and then we multiply it by 10 when you do it in real life. And that multiplication is because the asphalt test is done in one position, whereas you've got vehicle wander in real life. So when you take that away, the impact is going to be much higher. The way to model these things is really to adjust, number one, your damage load factors for your vehicles, or you can, of course, adjust the model sensitivity to the vehicles. So there's some very good work and examples in the literature that you can find on that, but very good observations. You're absolutely right.
Anybody else there got a question for Tians? Yes, Wena.
Hi, Theans. Good morning. You mentioned earlier what needs to be like incorporated in the model. You mentioned something on returns to investments for the improvements in resilience, and then you linked it with cost savings more. But what else are you thinking in terms of this returns on the investments for this, incorporating this resilience and the design of, the roads?
Absolutely. Well, the obvious other one that you need to start thinking about, and Ian has done quite a bit of work in this area, is the savings in carbon emissions that you get. If you've got some of these more resilient materials and construction techniques coming in, you do get some carbon savings. First of all, your embodied carbon, so that's a carbon you emit due to maintenance and the renewals work that you do. If something lasts longer, you don't have to go to the site that often. But there's even some performance enhancements where if your road is stiffer, if your road is more smoothly, for longer periods of time, your carbon emissions from your field-based vehicles is also reduced. So I think those are important things. Your direct cost savings to the agency, that's a major one. And then you can then also look at, for resilience improvements, the more socio-economic savings that you can get from a more resilient network.
Okay. Anyone else there, or else we'll let you go and have your, what are you up to? Afternoon tea? You're hitting?
Yeah.
Okay. So
Okay.
thank you, and we'll talk to you again later as well.
Thank you so much. Thanks for the opportunity.
Okay, we'll just bring up my slide deck next. So I've had the thrill of introducing a couple of people today I've known for several decades. I now get to introduce someone I've known all my life, and that is myself. So I'm just going to cover a little bit on the use of HDM and the greenhouse gas modeling. So hopefully we're getting close. Sorry, I distracted him with my next task at the same time as asking him to do this. So this is my fault. Sorry for that slight intermission. So what I'm going to cover is around the use of HDM4 and greenhouse gas modelling. So as I said earlier, this is something which was the subject of my PhD many years ago. It's also a topic which Neil and co have got me currently reviewing and updating for HDM5. The background also, was it last year, year before, Michael had myself and Eric Stannard, who's another one of the long-time HDM4 crew, develop a tool that looked beyond just the tailpipe emissions. So we looked at this in terms of being able to get a full holistic picture of the emissions. Where are we at too? Oh, here we go. So I think we've seen these sort of things plenty of times before. You know, greenhouse gas emissions, it's a big numbers. You can look at all sorts of reports, but it always adds up to a big dollar or a big environmental cost associated with the transport system. And additionally, for the World Bank, the ADB, Inter-American Development Bank and others, they've all made these commitments to reduce their, or to make sure their projects are aligned with the Paris Agreement. And so there's a process that projects go through, but the real question was, how do we know we're actually meeting that commitment? So against that is where Michael sort of stepped in and said, okay, guys, give us a tool that can actually look at this and say, are we doing the right things? And I guess also there's probably a bit of nervousness within the ADB that at the top end, there's these commitments, and yet such a big part of the lending is in the transport sector that it was like, are we still going to be able to actually do transport projects? So if you look at the total scope of what is in the greenhouse gas emissions, here on the road, we've got our internal combustion engines, we've got our EVs. But if you go upstream, you've got vehicles being manufactured, you've got power supply, service stations. For instance, about a third of the emissions of your vehicle actually happen before the fuel gets to your vehicle. So there's big upstream emissions. And then there was also all the emissions associated with works. Now, when we developed HDM4, we thought, and this is going back, mid-90s, we did the research, although the software didn't come out until 2000. We were doing well, and we modeled that. So, at the time, we thought we're well advanced. It was interesting. I don't think anyone ever looked at the outputs from HDM4 for emissions, probably for the next 20 years. Okay, we had one or two, but I think for most people, the emissions report was the unused, unloved cousin, and suddenly it became popular. And then we realized actually we had quite a constrained model as it was. So the model itself only does a limited amount of the overall emissions. It doesn't quite get the CO2 equivalents, because there's a couple of them there, methane and nitrous oxide, that we didn't model. So it's probably underestimating by a couple of percentage points, which in the context of all the other sensitivities is probably not too bad, but there are some items which are not quite correct there. The other thing we had to look at is the fact that there's a difference between emissions and who actually reports on those emissions. So if we look at it in the New Zealand context, if a road gets rough and there's higher vehicle operating costs because a vehicle wears out sooner, we recognise those costs in our New Zealand modelling. But all our vehicles are manufactured offshore. So the fact we have to buy more vehicles to do the same kilometrage doesn't actually cost us environmentally. It costs a different country environmentally. And if we've got EVs, the reporting for the power generation sits in a different bit of reporting. So what we tried to do was create this model that allows it to report all the emissions, but you can choose which ones you want to actually bring into your model to make it more flexible. So we wanted a model, it's credible, sensitive to the investments, because there's not much use having a model that's not, and could actually predict over those short and long terms. And I guess implicitly we were thinking this is something that would fill the gap until HDM5 comes along. Maybe it goes beyond that. Maybe it becomes the core of HDM5. Given my linkage from HDM4 through this into HDM5, there's a, you know, I guess we can draw some conclusions before the study's finished. But conceptually, what we've got is a model that looks at how a road deteriorates over time, and this is what HDM is doing doing itself, and that leads to some pavement deterioration. We get more deflections. The pavement gets softer, it gets rougher. Your rolling resistance goes up, and as a result, you use more fuel, so you get more emissions. At the same time, your vehicles wear out more often, so you need more vehicles to be manufactured. And then you also are doing work in here, which is the physical works, and back here you're constructing the road. Because we were picking up, the way our model's set up, this sort of sits outside of it, the initial construction. It can come in, but the part of HDM we were looking at was very much that aligns with all of this part. So lots of components to look at. As I said, that one in green is what HDM4 gives us sort of by default. And then we built the model around that to do all the rest. So if we look at this, HDM tells us what quantities of work we do, but it doesn't do any of this. HDM does this, but it doesn't do the vehicle manufacturing or any of these other parts. So we built a tool that expanded the capability of HDM4 to give us a full picture of things. So it links straight in, grabs out all the data, and then we build around it. The toolkit itself, there's a few inputs that we have to use. So for all the different work types, which again, it brings straight out of HDM for us, we put in the emissions associated with it. We put in the emissions associated with vehicles, but the tool also allows us to deal with transition of vehicles. So within it, we can actually look and say, if we've got a policy of encouraging a country to transition to EVs, we can say that we're going to take our old car to an electric car or whatever it happens to be. And then over here is quite interesting that if that policy also requires things like charging stations and other things to be constructed, we can also bring all those into the actual model. So when we are modeling in here, we're modeling a full scenario. So we can say this policy would achieve this, and here's all the things that go with that policy. The sort of outputs we get, so, well, the small bit, so we can set up whatever sort of transitions we want. So we can test and show, well, if we've got a highly congested 2-lane road, we can actually upgrade it to 4 lanes. The emissions and the works go up, but the emissions and the congestion comes down. So we can actually show that there are emission reductions from constructing roads. So there's all of that comes on. Equally, we can look at the impact here. If we reduce the budget for looking after a network of roads, we can show that, yes, you're doing less, so you're using less emissions, but the vehicle-based emissions are going up even quicker. So we actually end up overall in a worse situation. So not looking after the network, under-investing in the network, yes, you saved a little bit of works emissions, but actually drove your overall emissions up quite a lot. Like I said, it splits it out between the works, the vehicle running for ICEs or EVs, manufacturing, and also any other factors you wish to bring in, and we can get it all the way down to individual vehicle type. So what our analysis shows, and this brings us back to the green roads things as well that we've been talking about throughout the week, and a lot of what sits in this sort of decarbonisation space. Essentially, if we go above the road and below the road, so above the road, the figure here I've got borrowed off TN's. So a lot of it is pretty much telling us what you'd expect. We need to be optimizing our signals, that we can still justify additional lanes, bypasses, and all those things, that they still stack up as good engineering, the good environmental, the good economic solution. So these things don't go one or the other. They're not going against each other. So all of those things are all very, I think, pretty natural to us. It's what we would expect to happen. In-ground options and policies, again, a lot of these are what we would expect. But when you stand back and look at things, there are a few other contexts that come through. So one thing we have to identify is continually patching a bad road is actually bad economically. It's also bad environmentally. You know, maintenance patches have a high unit rate of GHGs, and they have a very short life cycle typically. So the unit rate of output of CO2 from a maintenance patch, especially when it's not one that's actually fixed the problem, is not great. And as Tian said, you know, if we've got a rough road, if it's, you know, high texture, high deflections, they all increase your rolling resistance of vehicles. So what we do know is that if we look after the road, we are also looking after the environment. So they're not counterproductive. We did the numbers in New Zealand, and on a typical sort of rural highway, you know, maybe you've got, you know, 5,000, 10,000 vehicles per day. The emissions by the traffic congestion at the work site to resurface the road will typically be greater than the emissions of the bitumen going on the road. So we get into that point of saying, well, you know, you might look at the bitumen and go, well, that's the oil, but it's the stuff you don't see is actually greater. So we need to be looking after the road. Not looking after the road is not a way to save the planet. You know, we need to make sure that we're not trying to save things, and this is where some of our projects, even in New Zealand, they've set targets on some of our big construction projects to reduce emissions during construction by 30%. And you go, that's great. You've just pushed up your life cycle emissions, which is far worse. You know, I would rather take the emissions up front. And we need to look at how we construct things that can be maintained. So again, I said on this one project near me, I said you should be building, and again, they wanted one lane each way. I said you should be building very wide shoulders so that in the future, when you come to maintain this road, you can keep it open all the time. Because I said the moment you have to shut this road to do work, you've offset every single saving you've made of emissions otherwise. We also have to do work efficiently. So the way we actually set out the time of the day we do works and how we actually do our closures becomes really important. And, you know, especially if you're in a busy network, you don't want those unplanned disruptions in the middle of the day. And you can always plant trees, which is, you know, it is multi. So, you know, planting trees, if you've got an area where you've got snow, you can stop that blowing across. It stabilizes the cuttings and everything else. So, you know, some of these initiatives, which again, those who sat in the Green Roads session would have seen, you know, things have a primary purpose, but they also have secondary benefits. And that's what you find. You know, you might plant a tree to, you know, sequester CO2, but it actually has a whole lot of other benefits for you across other aspects. So I guess really where we got to it that, you know, first of all, when we did this work, it reassured us that good asset management is actually also good environmental management, is also good economic management. We don't have a misalignment. It's not like you can argue I'm not looking after my network because of some other X, Y, Z. For the higher traffic, you know, the medium high traffic volume roads, you know, 80% or more of the emissions are coming out of the tailpipe of the vehicle. So therefore, it doesn't really matter what physical works you do, it's all about how you do it. Optimizing your work sites, time of day you do them, is going to have far more impact than, you know, tweaking, you know, a little bit of a decision around what you actually construct. It's not to say don't chase that, but if you put in your effort in, you know, you might save 1 or 2% on a better way to construct a road or low emission construction vehicles or different things. You could save far more than that by just saying, well, we'll do the road, we'll construct it in a different way. For very low volume roads, you know, if you're in remote Mongolia, for instance, then that balance starts to change and you get to the point where actually looking at how you construct it is also very important. And that last part, you know, again, that's good asset management and everything all links through. So that's all I wanted to say at that point. I don't know if there's any questions. Otherwise, we will move on to the next stage. But if you've got a question, I'm willing to take a question. Going once, going twice. You keep your hand down, Neil. I could see him twitching. He was like a gunslinger in a saloon. You could see him.
Well, no, it's a similar sort of question to the last one I asked, which is really when you're looking at EVs, because you mentioned, you know, emissions out of the tailpipe. But the one that you don't talk about are greenhouse gases. But what about particulates? So you're looking at, you know, tire wear, brake wear. And this has really significant health and environmental impacts, especially below 2.5 nanometers.
Yeah. I grew up and there's a truck depot nearby, and I love the smell of diesel first thing in the morning. In hindsight, I guess it was a particulate's probably settling somewhere inside me. But yes, I think it was, I'm not sure what the numbers are now, but I think it was about 40,000 early deaths a year in India alone, wasn't it, at one stage from particulate matter? So that's in the model. So the current HDM model for carbon basically it's a chemical reaction balance, because what it says is this is how much fuel you've consumed, so this is how much carbon is there by the atom, and then it goes through and says, well, some of it's in particulate, some of it's in, you know, all these different compounds, and it says, and if it's not in those, whatever's left must be in carbon dioxide. So that's actually the way it works. If anybody ever looks at the CO2 model in HDM4, and you wonder why there's funny numbers like 28.1 something or other, that is the atomic mass of the carbon monoxide element, or the, you know, methane element, or whatever it happens to be. So, well, yeah. So brakes and tires. Sorry. So there's the tire wear model in there. So I guess there's no reason why we shouldn't pick that up. Brakes, I don't think we've got a model in there at the moment. I can have a look. I'm pretty sure we don't. We've probably got the financial cost of it, but I don't think we've got one.
Hi, sir. Is HDM4 an open source and available for download? And when do we expect HDM5 arrival?
So HDM4 you purchase from an entity called HDM Global, which has the current licensing rights. Some of the reports are publicly available. Some you get from, you know, actually with purchasing the software. It's not particularly expensive. Yeah, 1,500 if you've, you know, yeah, dollars if you've got a ADB or World Bank or similar project going. Normally you can argue that they may wish to fund it. HDM4, I suspect we're 1 to 2 years before we'll see HDM5 actually out. And the discussion to date has been that there's the minimum viable product, so that'll be the one which gets out the door first, and then more modules will come on over the time. You were saying that there's, you know, if you buy HDM4 now, there's some potential licensing transition. Some discussion, yes. Okay, so yeah. But it's always been a question, even going right back to someone earlier today, was it your presentation, Michael, had like the old Watanatada books, this cover of them up on screen. And it's always been this, I don't know, I wouldn't say it's a debate because I don't think that's the right word, but where is the real value of HDM? Is it like HDM exists as a philosophy to start with? You know, it's a life cycle, the whole balancing trade-off things going on. Then there's the models and the equation, that side of the IP, and then there's the software itself that which brings it all together. So yeah, it's a multi-factor. So some of it, like I say, is available for download. Other parts you effectively get when you sign up. Anyone else there? We've done that. Excellent. Okay, we'll go to that Word document. Henry, do you want to, do you want to do Wiener's? No, I think we'll do the survey now. Sorry, we've just been moving things around because when we look around the audience and we're thinking as to who we've got here and how we can make really good use of you. So I think we do the survey on there. So do you want to lead us through the discussion line by line, Henry? So with this form that's coming out and that we'll give you, what we want to do is talk through these. You can make it as big as you like. What we're going to do is talk through these different initiatives. So these are sort of effectively the ones which Henry and Michael both talked about earlier. So the bit at the top, we just want to know what your, what sort of entity you're representing. But then we will just work through these to make sure that you understand it, what the item is. And really, if you see that something is to you is vitally important, write that. If you say you're not in supportive of something, you can put the big no, and go with with that. So the first part of it, very simple. It's what's your role, which I think we've done enough times that you probably have a pretty good handle on that. And then just sort of have you used HDM itself, the software, in the last 5 years. That's just so we understand a bit of what you're about there. So the next one, again, is provide modules that work seamlessly with ability to communicate to each other and utilize data from various external data sources and tools. This is sort of a high level objective. So I think it's fairly hard to argue against that. I don't think there was anything more detailed under that I saw from Michael's, rather from Eric's comments. So you're welcome to make a judgment, but I think that's sort of fairly obvious. Number 2 is to foster decision-making and selecting alternatives that enable optimization using user-defined objective functions. And I think the point there is really the user-defined. So, to be able to optimize not just on economics or not just on something, some other point, but to be able to get to the stage, maybe your objective is minimizing roughness. Maybe it is road safety, but actually to have a bit more flexibility in what it is that HDM is trying to achieve. Number 3, again, that's really an internal thing. If you looked at HDM4, you'll see that the research that we did, that was back in the mid-90s. The models themselves haven't really been updated, although there's been a lot of research undertaken in the years since. So that's more about, can we actually make this work? Can we come up with a solution that is far easier in a way to keep it up to date? So, at the moment, we don't deal with electric vehicles, but can we actually do that? Number 4, cloud-based native platform. Oh, sorry. Okay, apparently you want some time. There you go. That's excellent. We want more comments. The more, the merrier. So the purpose of this is that Michael can then assemble it all and make sure that he's fully captured the ADB view on things. So the next time himself or Jamie are involved in meetings on this, they have a bit more of a view of their wider usage or the wider ADB member usage. Yes. Now, I was actually getting to number 4 and thought I'd give people enough time. So number 4 is a big one. It's a cloud native platform that can be accessed globally. Now, that's one that I personally am none too fussed about. I understand the argument of, it's online, but I spend a lot of my time working in countries where the internet is not reliable, the power supply is not reliable, and to be shifting gigabytes of data upstream and downstream, having something sitting online is largely non-viable. Many others of you will be not having any of those issues at all. Some of the arguments around it allows them to keep the software up to date. I would argue that all my other software on my computer and my phone stay up to date pretty happily without being on the cloud. So, but equally, when Henry was talking before, he made some very valid comments about it as having software in the cloud and software as a service. So this is really something which I suspect we'll see more variation just based on the sort of IT environment people are in. Once we get through that, the next one is provide leading edge reporting tools. I think that's, again, it's something that's we do want. HDM4, as Henry said, was on a very initially very structured, well, it still was very structured or rigid sort of bit of software. So you couldn't really customize the reports unless you went completely outside and accessed data. So yeah, again, it shouldn't be too difficult. Number 6 is improving climate resilience. So that is, and the tool itself won't improve it, but it certainly, this is asking questions of, the ability to model an improvement in climate resilience. And that does bring us, create some additional data needs, because a lot of the resilience issues are happening off carriageway. So some of these issues, if we deal with them, it's how do we deal with it in a way that doesn't make a tool which is already considered data hungry even more so. And then the next one, around improving road safety. I think this is more around being able to integrate better with the likes of your IRAP models, is it not, Michael? That's correct, isn't it? The road safety is more about better integration with the special IRAP tools and not allowing for demonstrating the benefits of road safety. Yeah. Okay. So Mike was saying, being able to demonstrate better the road safety programs. So at the moment, for those who can't recall, HDM, effectively you tell it what safety reductions you really want in a piece of road. For those who are familiar with IRAP, Jigesh, you'll be familiar that it takes a huge amount of data at very fine segments. So it's sort of, how do you take some of those ideas and blend to be able to do this? The modeling the variable traffic composition. So this is really the transition to EVs over time. And related to that, of course, is to be able to look at the impact of different policies. So, you know, a country can actually start to look at, and similar to what we've done with the ADB toolkit, to be able to say, if I'm doing a policy that's going to, you know, really step up the transition from ICE to EV, how will that actually transition through the whole model? Number 9 goes somewhat against a whole lot of the others, because it's about, we want all these new things, but we also want to simplify the input data. So, you know, every time we add more model capability, we always add more data. And that, you know, that is in a way the reason why HDM4 has so many data inputs, is because their request last time, 30 odd years ago, was to allow it to model a lot more at that stage. So we had more vehicle types, we had more environmental conditions, but everything that comes in does end up with being, you know, more calibration factors and more and more and more of other stuff. Improving the environment. Can either Michael or Henry, can you recall what that particular element relates to? Number 10. I'm presuming at this stage we're into environmental. So unless it's you think, should we? Okay, we'll adopt that. Number 10 relates to the IT environment. There you go. Well, yeah, yeah. So that's all good. Then the number 11 is around risk. So that rather than just getting an answer, we get more of a risk-based answer. So, you know, being able to say, what's the likelihood that your network's going to be able to meet a certain target? So this isn't necessarily risk on one item per se, but if we look at the HDM4 models, what we would call deterministic models. So it says if X, Y, and Z is there today, in 15 years' time, the road's going to be exactly at this point, as opposed to saying, well, actually, there's a range of potentials out there. Some are more likely than others. And so how do we bring those sort of philosophies in? It brings you a better answer, but in some ways it makes it more challenging, because suddenly you've actually just got this distribution of potentials. Then we've got number 12, which Weena probably has no interest in all, saying to quantify wider economic impacts. So, which could be quite a significant one, because I don't know what your experience, Weena, but when I've worked on major projects, once you bring in the wider economic benefits, everything else is irrelevant, because the wider economic benefits just swamp the analysis by, 10, 20 times. Your traditional road user travel time savings are, the decimal point of the wider economic benefits. So it's quite a challenge that you work away trying to get your traditional economics correct. And then the wider economic benefits come in and you think, why did I waste my time? Because you're not even in the right, not playing on the right field.
Ask a question about that. Is that a question of kind of using HDM4 within a policy environment and policy context, and are those wider economic benefits sort of more at that policy setting? Like, decisions about how we're going to, not just the roads, but more.
Well, I think I'll pass to Weena.
Yeah, you're in the wind, right? Because the policy is not actually project, right? It's supposed to be a range of investment.
No.
So it should be people are. So the complementary investments are not incorporated in our current analysis. So, but if we only look at that specific project, it could be also that there could be some displacement that would happen because you're doing this project in some way. There's an opportunity cost. And we don't incorporate also that in our current analysis. That's why when we want to do this wider economic bench, I don't have a clue on how we can interface both in HDM4, because what we fear, and I was discussing with Elko this a while ago, is because we don't want that kind of like the duplication. We double count all these things, right? And then we kind of like have a, as Ian was saying, oh, you have such a wider, like, you know, bigger, okay, the magnitude would be different within just like, you know, our direct benefits versus this. But then when we consider and when we do modeling, you know, the assumptions there, and again, you know, even as we talk about data requirements of HDM4 or 5, the same requirement would be in we doing, you know, this modeling thing. So I was so we commissioned a study to do, but it's in transport but not in road, so it's rail. It's in the Philippines, and you know, it's an approved ADB project. It's north-south rail line, so it traverses like three regions, because in the Philippines you call, you know, a group of provinces regions. So it goes from north to south, south to north, north to south. And the modeling was really like, you know, it required an you know, land use data, household in the area, the firms locate, all the firms existing, you know, labor related data, et cetera, and the results again, you know, so they have, you know, in for modeling we have different scenarios. So we have, I think we've done 5 scenarios for this, and you know, it had, you know, the changes. Maybe, you know, when we say like a person, because in macro modeling, so it's more on the aggregate level, as you know, and as compared to when we do, you know, this, you know, project type analysis. So we need to think about how we can do this.
What I was going to say is, after we've done this part, we're going to get Weena to come up and run her session. Yeah, so then you can go through this in immense detail, and we'll all become a lot smarter, because I think out of all the changes, the one which has the potential to change the economics the most and everything is probably actually what happens here in terms of the wider economic impacts. Number 13, conduct an economic evaluation. I thought that's what we did already, so I'm not sure what exactly that. I hope that we were doing that for the last 30 odd years. I'm not sure why that's on the survey. Maybe it's just to make sure we didn't forget. Well, yeah, I'm not too sure. I thought that's sort of what we had was an economic evaluation tool. So unless it was meant to be valuation, not evaluation, but well,
like valuing ecosystem services and all these things.
Yeah.
Oh, that was it already.
Yeah, no, that's, yeah, I'm not like, unless you want to interpret it one way or another, I'm not too sure exactly what they're getting at there. Just to reiterate, the questions came from an external party. That's why we're using the form, so that we can feed into a wider discussion. Well, we can respond that we didn't understand. Improving presentation of the results of an analysis, I guess that in a way is similar to the reporting of earlier ones. So yeah, I don't think anyone's going to be too upset. Global access comes back to the cloud. So I suspect that's probably going to be a similar answer to what you already have given. Secure, scalable, and expandable platform, again, is probably similar to the earlier one. And then evaluating all classes of roads, which, you know, it does at the moment, but the question is whether or not it does them well enough. You can go back. Now at the bottom there, you'll find a few empty cells. This is where you are welcome to put in any other suggestions you would like. Then what I'd like you to do is, of the items, the ones you've written or otherwise, can you just go and, you know, put a star or a tick alongside the 5 that you consider the highest, priority, just to somehow indicate that you think, these are the things which really this model needs to touch on to be of use for me, that I would go out there and sell it and buy it and everything else. Okay, with high, medium, low, something like that. So however you wish to do it, but just so that we have a way of assessing, what it is that you would see as being important. High, medium, low, there we go. So high are the things which you're definitely there. Low, you just wouldn't miss it if it wasn't created.
People don't put everything as
high. Okay, so Henry here is of the philosophy that you love all your children, but not all of them equally. So he would like, what have we got? He would like to see 6. You would like to see 6 of each, would you? 5 of each? Yeah. Don't make it all high. Don't make it all low. Yeah, but that's, you've got to put one good X. You've got to add one item in. Now, if you wish to, I picked up an item that I was talking with Henry at lunchtime, at morning tea time rather. One area that we can do more, and this relates back to Serge's comment about the calibration, is having an automatic sort of data model validation report come through the system. So you can click on that and it will look at your data set, say, does that make sense? Are there inconsistencies? But also look at the calibration factors and the unit cost factors and different things and go, it won't stop you running it, but can actually flag and go, there are some unusual things going on here. I remember back in the days of HDM3 that people figured out that the easiest way to justify a road was to have lots of potholes. So it got to the point people would say, my road's got 200% potholes and therefore my actual investment's worthwhile. So I'm not sure how you have the pothole on the pothole, but the model didn't have the data checks to preclude that. So, the official voice of Georgia. So that's, once you've done, I'll come down and grab those forms and we'll pass to Wena. Do you want to run your workshop? But we'll do it as a general big room study. Yeah, can talk us through. Okay. That's okay. So Wena, you can come up and lead us through it. We've got about 20 minutes, 15, 20 minutes. So you can just talk us through it and we'll just do it as a big group because I think it is probably the most interesting challenge based on the questions people are getting. So I thank you for that and I'll pass over.
Sorry, I when Michael and Ian asked me, so I prepared something for a small group discussion. But anyway, I think there's interest and apparently so for the upgrade of the HDM4, so we want to incorporate this wider economic benefits in the model. Then we don't have to do things separately. I just want to show, because as I mentioned earlier, it's not standard or required or standardized in ADB that for our transport projects we require to do or incorporate and value these wider economic benefits. So we did one actually, and unfortunately So we did a study, but the paper is unpublished. But we reported it as part of our the project's economic due diligence. So this is in Bangladesh. So this is the Dhaka Sylhet Corridor Road Improvement. So road development project. So it's a project using, as I've mentioned earlier, a spatial CGE model. It's developed. It was done in coordination with IDE Tokyo, and it's a road project that connects to the border. It will widen, around 210 kilometers of existing 2-lane roads to 4 lanes. So it's gonna connect to some states in India, so Indian northern eastern state. So there's the baseline scenario there would be if you upgrade the road into 4-lane, so it can increase the speed from 38 to 50 kilometers per hour. So the assumption here is that the trade assumed to be driven by physical, so there would be a reduction in both in the physical and that the cost in terms of the travel due to the upgrading of the road. So the model, it creates a shock leading to changes in, so the assumption here, there will be changes in overall productivity, trade. So this, I'm just gonna show you what the model results. So you would see here a group of South Asian countries. So from Bangladesh, India, Bhutan, Nepal, Sri Lanka, and then we have PRC because they're one of the trading partners also of Bangladesh, and then ASEAN, US, EU, Japan, and the world. So, and then there would be sectors across. So this is, it involves agriculture, automotive, the textile, food processing, other manufacturing, service, mining. So the results show that based on the model, GDP for Bangladesh results in, this is in millions of dollars. Sorry, I wasn't able to put the unit. So it's 463.8. And then you would see for other countries, so there would be some for India because it's near the border, and then the others. So there's US, EU, Japan, and and it also reported results overall increase in GDP for the world. So the results of the analysis. So the model shows that countries can benefit from the road improvement. So because these are roads that would link into the neighboring countries. So some gains you would see for some northeastern states in India and other trading partners of Bangladesh. So we would see China, etc. So in the model, they included some scenarios. So if trade reform and custom facilitations are added as scenario, then that GDP column, it would be higher in the results, because if you added this additional like for example facilitation in procedures in the border, etc. So but then you would in the results it also showed that the vast majority of the benefits would actually accrue to Bangladesh in the services sector, followed by textile and transport. So mainly this project with this spatial CGE shows that the Bangladesh as an economy, because the estimation is in terms of the results are contribution to GDP, shows that benefits would go to Bangladesh. So this is not related to the direct user benefits of transport project, which also ADB provided in terms of the main analysis for the project. So you would see here that for this project, there's two economic evaluation undertaken. The first is for the direct user benefits, and then these wider economic benefits, which complements the results, which strengthens the rationale for supporting the project, which again goes back into that, when we develop transport investments, you say that the transport contributes to, the GDP of the economy, etc. Because, for trade, you use these logistics, etc. So again, so you capture actually both, the direct and the indirect benefits. What are the key takeaways? So again, when we do this appraisal of projects, we need to combine relevance with rigor. Relevance meaning that if you're claiming that this project, will do this, then you need to actually have some way of showing that. And of course, the rigor of the analysis needs to be undertaken. For some of, because of the need to do, wider economic benefits models are, it takes time to do. So sometimes the modelers, if we don't, as evaluators, if we really understand the model, there could be some simplifications being done, and we need to understand as evaluators on how it, why it is being constructed in that way. We want to stress here that the results of this are illustrative of potential effects. Again, similar to when we do cost-benefit analysis, they are based on assumptions. But the assumptions, as much as possible, we question those assumptions. We make it realistic. We make it, country-specific. Right, we need to adjust even if we base some of them in the literature. We need, as similar to doing HDM4 and what Alexander was saying earlier, you need local expertise for that. You need to question the assumptions that are being used. So in doing a full economic modeling exercise, so 4 things that we need to consider. So the resource constraints are imposed here in the model. Private sector responses are also considered in the model because, when we say transport improvements would generate private investments, etc., then we need to consider that. So the market imperfections should be explicit, should be, considered in the model. And then you have real income or the utility benefits are accurately, identified or estimated. Drawback of doing this type of modeling and, from experience, so this is doing this modeling, it's data and skills intensive. If you have resources, there are experts who do these things, but it's in terms of getting the data, it's well and good if you can get it to the, from national, you can get to regional, to, to local, the information that you can, the granular data is important. So the modeler, of course, you need to find a modeler that can actually work on and, given the difficulties also in data, can be able to, not manipulate, but be able to adjust, I guess. Yeah, I think that's the thing. We don't want the model to give out the results that we wanted, as was mentioned earlier, but we want the model to give us some indications, right? Given the realities on the ground. So we also want, as I've mentioned earlier, so it's quite expensive to undertake. So in ADB, we don't really, unless these are, when you call them transformative, very large infrastructure projects, they would do that because they want to showcase this project that, it can really, it has the potential. So that's the key world potential to deliver such types of benefits. Of course, it can, be helpful in, for usually, sorry. So we want it to complement what, our usual cost benefit analysis, as I mentioned earlier, which at this point can actually already support or justify the investments that ADB does. Similarly for DMCs, if you can justify it through the CBA, well and good. But if you can, do some types of analysis for your larger projects. Why not? Like especially if you have programs that big, infrastructure investments, not only in transport, but developing industrial corridors, for example. So it's not only transport that you would be required, right? So other types of infrastructure that would actually help your decision makers in, justifying why they need to put investments in that area versus other sectors, which are also equally important, especially other sectors like in the soft infrastructure, and also like for the development of the country. So I think. Thank you. If you want to read on this project, I can give you the link, or I have some material. Well, it's a 2-pager because we don't have the full report. Unfortunately, it's an unpublished document. So, but there's some description on what how it was done. Thank you.
Thank you. So before a question, actually, it's more of a concern. So, and I have to be honest here. So I do see the benefits of having these wider benefits described in the project assessment, something that would be relevant to the large projects, like in case of Georgia, full East-West highway assessment. But honestly, I would not want to see them in the HDM4 at all. Okay. Anything that is not directly sector specific, I think would not good there, because even for the road sector in HDM, every parameter is already have some assumptions requirement. It's already wild enough what results you get. And I would not want to justify the project with wider economic benefits. I mean, as a bonus, okay, this is good to have, but it should not be like part of justification. I mean, project should be healthy enough without them specific having benefits specifically from the sector. And just small example, actually, why I'm telling this. So many years ago in Georgia, government adopted a policy. So any government project above, I think, 5 million shell, it's about $2 million. So it should have economic indicators positive. And they prepared the kind of a template. So for agencies who use HDM4, they could use HDM4, but anyone could use whatever tools they had. And I remember there was several projects from municipality. It was road projects, like road rehabilitation, where the benefit streams, like 80% of their justification was actually due to increasing land price, which I don't really find it fair. I mean, when you can include again as additional information as extra, but it shouldn't be the core of the benefit. That's why I don't want to see them in HDM4. Thank you.
Yeah, so as mentioned, so in ADB also, as per our existing guidelines, so it's mainly we focus on the project benefits. But of course, you need to consider also if there are, when you do this project, you kind of like also think through what, are you affecting, drawing away some resources out of whatever. You need to internalize that as part of your project cost, right? But as you've mentioned also, if it's really like, because of this, one of the wider economic benefits is private investment. And so, change in land use, you drive residential, so there's residential development, commercial development, so increase in, do you want to include that as part of your, but that's, I guess that's, it doesn't, I don't think that one project will actually result also in that kind of like, with so we need to be cautious also on the attribution, because that one project may not necessarily, result into all this, increase in productivity, increase in private investment. So we take note of that. I don't know like how much we can actually incorporate or, calibrate that in if we put it in the HDM5.
Thank you. So just another thought. So even if it's ideal integrated in HTM4, another complexity I see that you need experts from so many different domains. Like it's not like some transport specialist that could build the model. You need like all kind of economists there. So I don't really, I think it will be a necessary complication, but I fully agree that having this as a part of the project appraisal, if possible, and if that is there, of course, definitely is beneficial. Thank you.
Any other questions here for? Right, I'll share my screen here one last time because we're very much coming to the end of the journey here. So we just want to do another, it's just a couple of questions, survey. So if you can connect up to this one. I learned long ago that the most important task of any workshop was to not roll into lunch. So that means as long as we can get this done quickly, we can all go to lunch on time and be happy. Everyone's connected there by the looks. So this is a post-assessment workshop. So again, just a similar question to the earlier. So what's your understanding now? Hopefully it hasn't got worse. Hopefully you haven't now discovered that you didn't know as much as you thought you did. I think there must be, not quite all the results. 19 results there. Must be similar to the number in the room. Okay, the next question. What do you know of HDM5, HRDM5? Hopefully you've all now heard that there is HDM5, so and I think there's one more, is there? Oh, it's about using HDM and climate change impacts, which relates to the Tian's and Alexandra's presentations. And I think that must be pretty much us based on numbers. So with that, I will thank you all for your contributions. Thanks to the speakers.